Hello, I'm Dr. Deepti, and we are looking at different concepts from maths under the heading Decreations Mathematics. We have been looking at different concepts from linear algebra and in matrices as well. Now, let us look at the concept of eigenvector and eigenvalue. It's one of the centralmost concepts in the field of linear algebra, and it has several applications including those in face recognition. So basically it's in machine learning, and there are several applications for that. So let us try to get introduced to these concepts. So the word eigen, it's a German word. It basically means own or typical or characteristic. So all of us know what is a vector. And you can, when you say vector, typically how we visualize it is as an arrow with length, that is the magnitude. And that arrow is obviously pointing in certain direction. So that means it is an entity which has both magnitude and direction. Now in the previous videos, we have learnt about linear transformations, and we have also learned about how it can be represented by a matrix. So when a linear transformation matrix acts on a vector, or the technical word which we use is operates on a vector, typically it tries to change its magnitude and direction. But then there are vectors like eigenvector. You can call them to that they are stubborn vectors, so as to say, because they don't want to change their direction. They want to keep their own direction. So this word eigen comes into picture there. So when this particular matrix, say A, acts on a vector V, you can maybe see it here. When a matrix A acts on a vector V, it doesn't change its direction. Instead, it just gets multiplied by a scaling factor. So it doesn't change its direction, it keeps its own direction. Instead, it gets scaled. That means it can get expanded or compressed. And this particular scaling factor, which we just now saw here, this is the scaling factor lambda. This is the eigenvalue. Again, the word eigen is part of this. So if it's a positive eigenvalue, the direction will remain completely unchanged. And if it's a negative eigenvalue, it will just get reversed. So for example, if the eigenvalue is -3, that means the eigenvector is tripled in length, but it is reversed in direction. Or if you say, if the eigenvalue is say +2, that means what is the situation? Eigenvector is doubled in length and the direction remains unchanged. So all of you must be familiar, those of you who have looked at eigenvector and eigenvalue earlier, you must be familiar with this. Those of you who are looking at it for the first time, this is a new concept that you should learn. So if A is a transforming matrix, as I said earlier, and V is eigenvector, then when this A acts on V, it gives you V back, but there is a scaling factor which is multiplying it. Let us take an example of a matrix and a vector 1, 1, 1. Let us try to multiply it. All of us must be familiar with matrix multiplication by now because we have done lots of videos on it earlier. If you are still not very sure, please refer to our earlier videos in decreations mathematics. So let us multiply it. We know how we multiply it. Row of this and this column. It's a single column here. So here there's no suspense, right? So 1 into 1 is 1, 2 into 1 is 2, and 1 into 1 is 1. When you add it up, it's going to give you 4. Similarly, if I multiply this row and this column, you will find that that also gives you 4. And similar situation is with last row as well. So when you are multiplying this particular vector with this matrix, you are able to get the basic matrix as 1 1 1, that means the same column vector but multiplied by 4, because if you had taken clear multiplication you would have got here 4 4 4. We have already taken 4 common, so that this remains to be the original column vector 1 1 1. So this is the idea of this particular equation. When A acts on a vector, it gives you back the vector but with a certain multiplicating factor, scaling factor. Now, for example, in this case, due to this particular matrix, magnitude of V becomes 4 times and direction remains unchanged. So this is just an introduction to eigenvector and eigenvalue. We are going to do many videos on this and learn this in depth because it's a very, very important and central concept. So this is the takeaway of this video. This particular equation, AV is equal to lambda V, where A is transforming matrix, V is eigenvector, and lambda is eigenvalue. Thank you.